The irrigation system failed at 2:17 on the hottest afternoon of the summer. Daniel Bennett noticed it first. The steady hiss of sprinklers across the apple orchard stopped without warning. One moment, water was reaching the youngest trees. The next, the rows were silent. Daniel checked the storage tank on the hill. It was nearly full. He checked the pump. The motor was still running, but at the far end of the orchard only a thin stream dripped from the last sprinkler head. Within minutes, several young apple trees began folding their leaves against the heat. Mara Bennett found her father beside the pump house, staring at the pressure gauge. "It dropped again?" she asked. "Almost to zero. Did the pump stop?" "No." Daniel shut the system down before the motor overheated. This was not the first failure. 3 professional teams had already worked on the problem. The first replaced part of the pump assembly. The second changed the check valve, cleaned the filters, and inspected the main line for blockage. The third increased the operating pressure and recommended replacing the entire irrigation system. Each repair worked briefly. Then the pressure fell again. The Bennett family had spent most of its emergency savings without finding the cause. Now the third team's written estimate lay on the dashboard of Daniel's truck. A complete replacement would cost more than the orchard was expected to earn that year. Daniel looked toward the rows of young trees. "If we cannot run the system tonight, we start losing them tomorrow." Mara opened the nearest outlet valve. At first nothing came out. Then the pipe gave a sharp knock. A burst of water entered the collection trough, followed by several large bubbles. Mara filled a clear glass from the outlet. More bubbles rose through the water. Daniel barely looked at them. "We have already checked the filters. This does not look like dirt. It could be air from the empty section. The tank is full, and the pump is running." Daniel wiped the sweat from his forehead. "What are you saying?" "I don't know yet." Mara listened as the pipe knocked again. She had heard that sound before, usually after the system had been shut down and restarted, but now it happened while the pump was still trying to move water. She looked uphill toward the storage tank, then followed the buried root of the pipeline with her eyes. The technicians had focused on the pump, the valves, and the sprinklers. They had checked where the water entered the system and where it was supposed to leave. Mara began thinking about what happened between those 2 points. She held the glass toward the sunlight. Another bubble reached the surface. "If mud was blocking the pipe," she said, "why would air keep coming out?" Daniel looked at the glass. For the first time that afternoon, he stopped watching the pressure gauge. The orchard still had water. The pump still had power. But somewhere underground, something was preventing the two from reaching the trees. Mara set the glass beside the pump house. Then she took an old map of the irrigation line from the wall. 3 professional teams had tried to force more water through the system. Mara decided to find out what was stopping it. The first repair team blamed the pump. They replaced a worn impeller, adjusted the motor, and restarted the system. For several hours, the pressure returned. By the next afternoon, it dropped again. The second team inspected the filters, check valve, and main line. They found no major leak, but replaced 2 valves and flushed the pipes. The system worked for 1 full cycle. Then the sprinklers weakened from the far end of the orchard toward the pump house. The third team arrived with electronic gauges and a pressure test unit. They increased the pump setting and tested each irrigation zone separately. At first, the stronger pressure forced water through the line. Then the pipes began knocking. The flow became uneven. Within minutes, the pressure fell again. Their conclusion was simple. The old system was badly designed and should be replaced. Daniel accepted the written estimate without arguing. Mara did not. She asked the lead technician one question. "Where does the pressure disappear?" "At several points," he said. "Which point first?" He looked at the readings. "We did not monitor every section continuously. The team had tested the pump. They had tested the outlets, but no one had followed the pressure through the entire route while the failure happened." After they left, Mara placed gauges at 3 locations: near the pump, halfway through the main line, at the first orchard zone. She restarted the system. The pressure near the pump remained high. The middle gauge began to fluctuate. The gauge inside the orchard dropped soon after. The problem was not beginning at the pump. It was developing somewhere between the hill and the trees. Mara listened carefully. A low knocking sound moved through the buried pipe. Then came a short rush of water. Then silence. She marked the time in her notebook. The same pattern appeared again during the next test. Strong pressure at the start, unstable pressure in the middle, weak flow at the end. Daniel stood beside her. 3 teams checked that line. They checked for leaks and blockages. What else could stop water? Mara looked uphill. Something that moves. The answer was not complete, but it narrowed the search. The next morning, she began walking the buried pipeline from the pump house to the orchard, looking for the exact place where the pressure changed. Mara began before sunrise. The air was cooler then, and the irrigation system usually worked longer in the morning than it did during the afternoon heat. She carried the old pipeline map, a pressure gauge, a wrench, and a notebook. The map showed a direct route from the storage tank on the hill to the orchard below. On paper, the line appeared simple. In reality, much of it had been buried more than 20 years earlier. Parts of the hillside had been repaired after storms. Soil had shifted, new fence posts had been installed, and one section of the service road had been raised. The map showed where the pipe had originally been placed. It did not guarantee that the pipe still followed the same slope. Daniel watched Mara fasten the gauge to a service valve near the pump house. "You are testing it again? I want to compare the morning readings. We already know it works better when it is cool." "That may be important." Daniel looked unconvinced. To him, temperature affected the trees, the soil, and the demand for water. Mara suspected it might also affect whatever was trapped inside the pipe. She started the pump. The pressure rose steadily. Water reached the first orchard row, then the second. For nearly 20 minutes, the system worked normally. Mara recorded the reading every 2 minutes. Then the middle gauge began to move. The needle rose sharply, dropped and rose again. A dull knock traveled through the buried line. Several seconds later, the far sprinklers weakened. Mara wrote down the exact time. Daniel stood beside the pump. "It is happening again." "Yes." "What does that tell you?" "That the pump is still producing pressure when the orchard starts losing flow." She turned off the system. The pipe knocked twice after the motor stopped. Then air hissed from the nearest outlet valve. Mara added another note. The failure always followed the same sequence: stable flow, pressure fluctuation, knocking, air release, weak water at the end of the line. She spent the morning walking the buried route. Every 50 feet, she marked the ground with a small flag. At each service point, she checked the pressure and listened to the pipe. Most sections were quiet. Near the middle of the hillside, she heard a faint, hollow sound beneath the ground after the system shut down. She checked the map. According to the drawing, the pipeline should have been descending continuously at that location, but the ground in front of her rose slightly before dropping toward the orchard. The difference was easy to miss. Years earlier, a landslide had damaged the service road. The repair crew had filled and raised part of the slope. If the buried pipe had moved upward with the soil, this section could now be higher than both sides. Mara drove a stake into the ground. That afternoon, one of the technicians from the 3rd repair team returned to collect a pressure unit they had left behind. He found Mara measuring the slope with clear tubing and 2 wooden stakes. "What are you doing?" he asked. "Checking the elevation of the main line. The line is shown on the plan. The plan is older than the road repair." He glanced at the stakes. "You think a few inches of elevation caused all this?" "I think something is gathering here." The line was flushed. That would remove debris. And air. Only if the air had a clear way to leave. The technician looked toward the pump house. "The system needs more consistent pressure. It already has pressure at the pump. Then there may be internal pipe damage." "Would internal damage make it work longer in the cool morning?" He paused. "It could affect several things." It was not an answer. Mara had become used to that. The professionals spoke to Daniel when discussing repairs, costs, and decisions. When Mara asked questions, they treated them as interruptions. She did not have an engineering degree. She had grown up operating valves, cleaning filters, and repairing sprinklers beside her father. She knew how the system sounded when it was healthy. That did not make her an expert, but it made the new knocking impossible for her to ignore. After the technician left, Mara continued measuring. The ground near the marked stake was nearly 14 inches higher than the line suggested by the original map. That did not prove the pipe had risen by the same amount, but it gave her a location to test. She installed temporary pressure gauges on both sides of the suspected high point. Then she restarted the system. For the first 10 minutes, the readings stayed close. After 20 minutes, The lower gauge remained stable. The gauge beyond the raised section began fluctuating. The pipe knocked beneath Mara's boots. Then the pressure on the orchard side dropped. She shut the pump down. A few seconds later, a long hiss traveled through the line. Daniel heard it from several yards away. That was air. Yes. Where did it come from? Mara pointed to the raised section. I think it is collecting under us. Daniel studied the ground. If you are right, why did none of the teams find it? They checked the equipment. So are you saying they did not know what they were doing? No. Mara closed her notebook. They repaired the parts that usually fail. She looked down at the stake. But this may not be a broken part. It was a simple distinction. A pump could be replaced. A valve could be cleaned. A cracked pipe could be repaired. But trapped air could disappear during one test and return during the next, especially if no one examined the highest point in the line. Mara still needed proof. She could not dig up the entire hillside based on a sound and several unstable readings. She needed to reach the pipe at the suspected high point and determine what was inside it. Daniel looked toward the orchard. The leaves on the youngest trees were already tightening in the heat. How long will that take? One test. And if you are wrong, we lose a few more hours. And if you are right, Mara picked up the wrench, then we stop replacing everything except the actual problem. Mara returned to the suspected high point before noon. The pipeline was buried beneath a raised section of the service road. Digging it up would take hours, so she began with a simpler test. She opened the nearest outlet downhill from the marked section and restarted the pump. At first, the water came out normally. Then the flow weakened. The pipe beneath the road gave a dull knock. A second later, the outlet released a burst of air mixed with water. Mara held a clear container beneath it. Large bubbles rose immediately. Daniel watched from beside the valve. That could just be air entering when you opened it. Then it should stop. They waited. The bubbles continued. Mara shut the outlet, allowed the pressure to build and opened it again. The same sequence repeated. Water, knocking, air, weaker flow. She performed the test 3 times. Each result was nearly identical. The problem was no longer only a suspicion. Something inside the line was repeatedly collecting air and releasing it in bursts. Mara reviewed her notes. The system lasted longer in the morning, failed faster in the afternoon, knocked before the flow dropped, released air after shutdown. Those details pointed toward the same possibility. As the day became hotter, air trapped inside the pipe expanded. The larger pocket reduced the space available for water and disturbed the pressure beyond the high point. The pump responded by pushing harder, but extra pressure did not remove the trapped air. It compressed it. Daniel looked toward the raised road. So the line is not completely blocked. No. Water still passes through, until the air pocket becomes large enough to interfere with the flow. Why does the system sometimes work after we restart it? The pressure may move part of the air. Then it gathers here again. Daniel folded his arms. And that knocking? Water hitting the trapped air, or the pressure changing suddenly around it? Mara did not claim certainty. The sound could also be caused by loose pipe supports, valve movement, or a sudden change in flow. But combined with the bubbles and the pressure readings, trapped air had become the strongest explanation. She needed direct access to the line. Daniel brought the small excavator from the barn. They removed the road surface carefully, stopping whenever the bucket approached the expected pipe depth. After nearly 2 hours, Mara uncovered the main line. The pipe had not broken, but the repaired roadbed had lifted the section into a shallow arch. Both sides of the line descended away from the exposed point. It was exactly the kind of shape that could trap air. Daniel examined it. That was not on the original plan. It probably did not exist when the plan was drawn. The pipe had moved with the ground after the old road repair. The 3 teams had inspected the original layout. They had not considered that the landscape had changed the line itself. Mara cleaned the dirt from a threaded connection near the top of the arch. She placed a wrench on it. Daniel stopped her. The line may still be under pressure. I know. They shut down the pump, closed the lower valves, and waited for the gauge to fall. Mara loosened the connection slowly. Nothing happened at first. Then a sharp hiss escaped from the threads. Daniel stepped back. The hiss continued for several seconds before water began leaking from the joint. Mara tightened it again. Neither of them spoke. The sound had confirmed what the gauges could not. Air had been trapped at the highest point of the line. Daniel looked toward the orchard. So that is it? It is the location. But opening the joint every time is not a repair. No. And if we leave it open, we lose water and pressure. Mara nodded. She had found the cause. Now she needed a way to release air without allowing the water to escape. The insight was simple. The system did not need a stronger pump. The air needed its own exit. Finding the trapped air was not enough. Mara needed to understand how it kept entering the system. If the cause remained, any repair at the high point would only treat the symptom. She began at the storage tank. The water level was high enough to supply the main line, and the intake remained fully submerged. The filter was clean. There was no visible leak near the pump. She restarted the system and watched the pressure build. For the first several minutes, the flow remained steady. Then the familiar knock traveled through the pipe. Mara returned to the exposed high point and placed one hand against the line. The pipe vibrated beneath her palm. Air was gathering there again. Daniel stood beside her. We released it less than an hour ago, which means new air is entering somewhere upstream. They inspected every accessible connection between the tank and the raised section. Most were dry. At an old coupling near the pump house, Mara noticed a dark ring around the threads. It was not leaking water while the system was running, but when Daniel shut down the pump, the pressure inside the line fell quickly. Mara poured soapy water around the joint. As the system cooled and drained slightly, the liquid pulled inward. The coupling was drawing air into the pipe. Daniel examined it. If it can pull air in, why does it not leak water out? Because the pressure changes. When the pump ran, internal pressure helped seal the weak joint. When the system stopped and water moved downhill, a slight vacuum formed near the upper section. The damaged coupling allowed air to enter. That air traveled with the next startup until it reached the highest point, where it could no longer move easily. The first team had repaired the pump. The second had replaced larger valves. The third had increased pressure. None of those actions addressed the small intake leak or the raised pipe section where air collected. Mara removed the old coupling. The seal inside was cracked and flattened. Daniel turned it in his hand. That small piece caused all this? Not by itself. She pointed uphill. The seal lets the air enter. Then she pointed toward the exposed arch in the pipe. And that high point traps it. The problem required both conditions. A new seal alone might reduce the air, but would not give existing pockets a reliable exit. A vent alone might release the air, but the system would continue drawing more in. Mara replaced the coupling and restarted the pump. The line ran more smoothly. The knocking became less frequent, but it did not disappear completely. Some air remained inside the system, and smaller amounts could still enter during maintenance, shutdowns, or changes in tank level. Daniel watched the orchard sprinklers. The pressure is better. For now. So what is still missing? A permanent exit at the highest point. Mara marked the top of the exposed pipe. The solution no longer required replacing the entire irrigation system. It required two precise repairs: stop unnecessary air from entering, release unavoidable air where it naturally collected. The insight was simple, but the next step had to be done carefully. A poorly placed vent could leak water, reduce pressure, or create another failure point. Mara opened her notebook and drew the raised section of pipe. Above it, she sketched a small vertical connection. Daniel looked over her shoulder. That is all? If it works properly? And if it does not? Mara closed the notebook. Then we learn before we trust it with the whole orchard. Mara did not install a permanent valve immediately. She wanted proof that releasing air at the raised section would restore the system, not just for a few seconds, but long enough to show a clear connection between the trapped air and the pressure loss. She began by preparing a temporary test point. The exposed section of pipe already had a threaded connection near the top of the arch. Mara removed the plug and attached a short vertical pipe with a manual valve at the end. It was not designed to remain there permanently. Its only purpose was to let her control when the trapped air escaped. Daniel inspected the connection. "You are sure this can handle the pressure?" "For the test, yes, but we open it slowly. And if water comes out, it should. That tells us the air is gone." Mara placed pressure gauges at 3 locations, one beside the pump, one below the raised section, one near the final orchard row. She also positioned a clear hose at the temporary valve so they could see whether it released air, water, or both. The first test began shortly after sunrise. The system usually performed best in the cooler morning air, so Mara wanted a normal starting point before forcing it to fail. Daniel started the pump. Pressure rose near the pump house. Several seconds later, the middle gauge responded. The orchard sprinklers came on last. For the first 15 minutes, all three readings remained stable. Mara wrote them down every 3 minutes. Pump pressure, pressure below the high point, pressure at the orchard. At 19 minutes, the middle gauge began to shake. The far sprinklers lost part of their reach. A dull knock came from the exposed pipe. "There," Mara said. Daniel looked at the gauges. The pump was still producing nearly the same pressure, but the gauge beyond the raised section had begun falling. Mara moved to the temporary valve. She did not open it fully. She turned it only a fraction. A sharp hiss escaped through the clear hose. No water appeared at first, only air. The middle gauge steadied slightly. Mara opened the valve a little more. The hiss became louder. Then came a broken mixture of air and water. The orchard pressure began rising. Daniel looked toward the last row. The sprinklers that had weakened moments earlier started extending farther again. Mara kept the valve open until the flow through the clear hose became continuous. No more bursts, no more bubbles, only water. She closed the valve. Within less than a minute, the orchard gauge returned close to its original reading. Daniel watched the needle. That fast? Mara checked the pump gauge. It never lost pressure at the source. So the pump was pushing against the air pocket, and the water could not pass it evenly. They allowed the system to run for another 40 minutes. The pressure remained stable. For the first time in days, the irrigation cycle reached the last row without collapsing. But Mara did not call the test complete. One successful release could still be coincidence. She shut down the system and waited. As the water settled inside the line, the pressure fell. The newly replaced coupling no longer drew visible air, but the pipe system still contained small amounts from previous shutdowns and maintenance. They restarted it in the afternoon, when the problem normally appeared faster. The outside temperature had risen sharply. The first 10 minutes were normal. Then the middle gauge began fluctuating again. The knocking returned, though less violently than before. Mara opened the temporary valve. Air escaped immediately. The orchard pressure recovered again. The same action produced the same result. They repeated the test a third time near sunset. This time, Mara did not release the air as soon as the gauge moved. She allowed the pressure to fall farther so they could compare the full failure pattern. The far sprinklers weakened first. Then the next row, the pressure below the high point dropped while the pump gauge remained strong. Only then did Mara open the valve. A long stream of air left the pipe. The pressure beyond the raised section recovered in stages. First the nearest orchard zone, then the middle rows. Finally, the last sprinklers returned to full flow. Daniel stood beside the final row, watching the water reach the trees. "We spent weeks changing equipment," he said, "and none of it removed the high point. The pump was not failing. It was working harder because the system could not move water properly." Daniel looked uphill toward the small temporary pipe. That simple valve did more than 3 repair teams. It only confirmed the cause. It turned the water back on. For now. Mara knew the difference mattered. The manual valve required someone to watch the pressure and open it at exactly the right time. If opened too far, it released water. If forgotten, the air would collect again. If left open, the system could lose pressure continuously. The temporary test was proof. It was not yet a safe solution. Mara recorded the results in her notebook. Pressure stayed high near the pump during failure. Pressure dropped after the raised section. Air escaped before water at the temporary valve. Releasing the air restored flow immediately. The pattern repeated 3 times. At the bottom of the page she wrote, "The obstruction is not solid. It is trapped air at the highest point of the line." Daniel read the sentence. "So we install a permanent vent there, a vent that releases air automatically and closes when water reaches it." "Yes." "Can we build one?" Mara looked at the temporary pipe. "We should not build the internal mechanism ourselves." Daniel understood. A homemade opening was easy. A reliable valve that handled changing pressure without leaking was different. They needed a properly rated air release valve, the correct connection size, and a protected installation that would not be damaged by machinery or soil movement. Mara had found the simple insight, but applying it safely still required precision. The next morning she called the irrigation supplier and asked for a small automatic air release valve designed for pressurized agricultural lines. The salesman asked where she planned to install it. At the highest point. There was a pause. Do you already have a vent there? No. That may explain your pressure problem. Mara looked toward the orchard. 3 professional teams had searched for something broken. The system had only needed a place to breathe. The automatic air release valve arrived 2 days later. It was small enough to fit in Mara's hand. Daniel turned it over. This is supposed to save the orchard? If it is installed correctly. Mara attached the valve to a short vertical pipe above the exposed high point. She used the existing connection from the manual test and added a shutoff valve beneath it so the unit could be serviced later. The installation looked simple. That was why she missed the risk. The temporary pipe stood directly above the highest point, but the ground beneath it was loose from excavation. Mara had not yet built a proper drainage area around the valve. She expected mostly air to escape. During the first test, that was exactly what happened. The pump started, the valve hissed for several seconds, then closed when water reached it. Pressure remained stable through the orchard. Daniel walked to the last row. Every sprinkler was working. For nearly an hour, the system ran without knocking or losing pressure. It is fixed, he said. Mara looked at the gauges. The readings were better than they had been in weeks, but she still wanted to observe a full shutdown and restart. They stopped the pump for lunch. As the line drained slightly, more air entered through normal changes in pressure. When Mara restarted the system, the valve opened again. This time, air came out with a sudden burst of water. The spray struck the loose soil around the pipe. Mara moved toward the valve, but it closed before she reached it. A shallow puddle had already formed. That should not be enough to matter, Daniel said. Mara examined the wet ground. Not once. They continued the test. Each startup released another small amount of water. The soil softened. By late afternoon, the vertical pipe had begun leaning. Mara shut the system down. The threaded connection had not failed, but the ground supporting the assembly was washing away. If the pipe leaned farther, it could crack the main line. Daniel looked at the eroded hole. So the valve works. The location works. But the installation does not. Mara removed the automatic valve before more damage occurred. She had focused on releasing air safely from the pipe. She had not planned for the water that could leave with it. The amount was small compared with the irrigation flow, but it always struck the same unprotected spot. Repeated often enough, it became destructive. The mistake taught her that the solution needed more than the correct valve. It required a stable riser, controlled drainage, and protection from movement. Mara drew a revised installation. The vertical pipe would be supported independently instead of placing its weight on the main line. The valve outlet would drain through a short hose into a gravel-filled basin. A protective box would keep dirt, insects, and equipment away from the mechanism. The shutoff valve would remain accessible for inspection. Daniel studied the sketch. The first version took 20 minutes. This one will take most of the day. Still simpler than replacing the system. Yes, they removed more soil around the main pipe and confirmed that it had not shifted. Then they installed a supported riser beside it and connected it with a short, flexible section. The flexibility reduced the chance that ground movement would place stress on the buried line. Around the outlet, they built a gravel basin large enough to receive the small amount of discharged water without causing erosion. Mara mounted the automatic valve above the expected water level and added a protective cover with ventilation openings. By evening, the system was ready for another test. Daniel reached for the pump switch. Mara stopped him. "Tomorrow morning. Why wait? I want the sealant fully set, and I want enough daylight to inspect every connection." The old Mara would have rushed to prove that the idea worked. The failed berm on the hillside and the washed-out valve installation had taught her otherwise. A correct insight could still produce a bad repair if the details were ignored. The next morning, Mara inspected the supports, opened the isolation valve, and started the pump. Air hissed from the automatic valve. A small amount of water followed and drained into the gravel basin. Then the valve closed. The riser remained steady, the ground stayed intact. At the far end of the orchard, the sprinklers came on one row after another. Mara watched the gauges for the familiar fluctuation. It never came. Daniel stood beside the exposed line. "You were right about the air." Mara shook her head. "I was right about where it was trapped." She pointed toward the rebuilt installation. Fixing it took more than opening a hole. The simple insight had revealed the solution. The first mistake had made it reliable. The rebuilt vent assembly stood above the buried pipeline like a small metal post. It was not impressive. There was no new pump, no new control panel, and no expensive network of replacement pipes. Only a supported riser, an automatic air release valve, and a gravel basin beneath it. Mara inspected every connection before starting the system. She checked the flexible coupling between the riser and the main line. She tested the isolation valve. She made sure the protective cover did not block the vent opening. Then she placed pressure gauges at the pump house, below the high point, and near the final row of apple trees. Daniel waited beside the switch. "Ready? Start it slowly." He opened the main line and turned on the pump. The gauge near the pump began to rise. A few seconds later, the automatic valve released a clear hiss. At first, only air escaped. Then came several uneven bursts of air and water. The discharged water fell through the outlet hose and disappeared into the gravel without disturbing the soil. Mara watched the valve closely. As soon as a steady column of water reached the riser, the internal float lifted and closed the opening. The hissing stopped. The first orchard sprinklers came on. Then the middle rows. Finally, water reached the weakest section at the far end. Daniel looked toward the final row. Each sprinkler produced a steady arc. "No knocking," he said. "Not yet." Mara recorded the first set of pressure readings. The pump gauge was stable. The pressure below the high point no longer fluctuated. The final orchard gauge rose slowly until it reached the level expected for normal operation. They allowed the system to run for 1 full hour. During previous tests, the pressure would usually begin falling within 20 minutes. This time, the needles barely moved. Mara walked the entire orchard. She checked for weak sprinklers, wet areas that might indicate leaks, and unusual vibration in the exposed section of pipe. Everything appeared normal, but a single successful run was not enough. She wanted to know how the valve behaved when the system shut down and restarted, the moment when air was most likely to enter or move through the line. Daniel stopped the pump. Water continued moving downhill for several seconds. The pressure gauges fell gradually. Mara stood beside the vent assembly and listened. The valve opened with a quiet click. Air entered through it as the pressure inside the line changed. Daniel looked at her. "It is letting air back in. It is preventing a vacuum. Is that good?" "In this system, yes. If the line drains slightly, it needs controlled air entry. Otherwise, the negative pressure could stress the pipe or pull air through damaged seals." The difference was important. Air inside a pipeline was not always a problem. Uncontrolled air entering through leaks and collecting at high points was the problem. The valve gave the system a designated place to release and admit air as pressure changed. 10 minutes later, they restarted the pump. The vent opened immediately. The trapped air escaped before the pressure reached the orchard. A small spray of water entered the gravel basin. Then the valve closed. The final gauge rose without hesitation. Again, there was no knocking. Daniel watched the sprinklers turn on. So every time the system starts, the air leaves here. Most of it should. And when the line stops, the valve helps prevent the pipe from pulling air through weak connections. He looked at the small assembly. One valve handles both? This model is designed for that purpose. They repeated the cycle 4 more times. Mara varied the test each time. She opened only one irrigation zone, then 3 zones at once. She allowed the system to remain off for half an hour before restarting it. She also reduced the tank level to simulate conditions later in the summer. Each time the valve released air at startup and closed when water reached it. The pressure remained stable beyond the high point. By afternoon, Mara had several pages of readings. The old failure pattern had disappeared. Before the repair, the sequence had been predictable: stable startup, fluctuating middle pressure, pipe knocking, weak flow in the orchard, air released after shutdown. Now the sequence had changed. Air released immediately, pressure increased evenly, the valve closed. The orchard completed its full cycle. Daniel looked through her notes. So the third team was wrong about replacing everything. They were wrong about the main cause. They wanted a stronger pump. A stronger pump might have forced water through for a while, but the air would still collect. Yes, and higher pressure could have created more stress elsewhere. Mara did not believe the professional teams had been careless. Each one had approached the system through its specialty. The pump team examined the pump. The pipeline team looked for physical blockage and leaks. The irrigation team measured performance at the orchard, but the failure occurred between those areas. The system looked functional when its parts were considered separately. The problem only became visible when Mara followed how water, pressure, and air moved through the entire line. Before sunset, she covered the exposed pipe with clean soil while keeping the vent assembly accessible. She compacted the soil carefully around the main line, but left the riser independently supported. The gravel basin remained open beneath the outlet. A bright marker post stood beside the protective box, so no tractor or mower would strike it. Daniel helped replace the service road surface. When they finished, almost all evidence of the excavation had disappeared. Only the small covered valve remained. "It does not look like much," he said. "It should not need to." They started one final irrigation cycle. The pump came on. The valve hissed briefly. Then water moved quietly through the hillside. At the far end of the orchard, the last sprinkler rose and began turning. Daniel stood beneath the spray. For weeks, that row had received only a weak stream. Now water reached the full width of the trees. Mara walked from one row to the next, checking the leaves and soil. The youngest trees had begun showing heat stress. Their leaves were curled and the top layer of soil was dry, but the roots were still alive. The repair had come before the damage became irreversible. Daniel joined her near the final row. "How long before we know it is truly fixed? A full irrigation cycle is good. And better than that? Several days of shutdowns, restarts, and afternoon heat." He nodded. There was still reason to be cautious. The valve could clog. The damaged coupling could loosen again. Another hidden high point might exist farther down the line. But the main pressure failure had stopped. The orchard was receiving water. That evening, Mara placed the old glass from the pump house beside her notebook. During the first failure, it had filled with bubbles. Now the water from the final outlet ran clear. Daniel picked up the glass and held it toward the light. No bubbles. Mara looked toward the small valve on the hillside. They are leaving before they reach the orchard. 3 professional teams had tried to repair the system by adding power, replacing components, and increasing pressure. Mara had solved the central problem by asking one simpler question. Where would the air go? The answer was not the pump house. It was not the final sprinkler. It was the highest point in between. Mara did not call the repair successful after one day. For the next week, she monitored every irrigation cycle. She recorded the startup pressure, the time needed for water to reach the final row, and the amount of air released from the valve. She also checked the gravel basin for excessive discharge and inspected the riser for movement. On the first morning, the valve hissed for 6 seconds before closing. The system then ran for 90 minutes without losing pressure. That afternoon, the outside temperature rose above 95 degrees. Previously, the irrigation line had begun knocking within 20 minutes under similar conditions. This time, the valve released a short burst of air during startup, then remained closed. The pressure at the last orchard row stayed steady. Daniel walked the line twice, expecting the flow to weaken. It did not. On the second day, Mara tested 2 orchard zones at once. The pump worked harder, but the pressure remained within the normal range. Water reached the final sprinklers without the violent fluctuations that had appeared before the repair. Daniel checked the pump housing. "It is running cooler," he said. "It is no longer pushing against the air pocket." So the pump was not only losing flow, it was wasting energy trying to maintain pressure. The old system had seemed too weak because part of its effort was being lost inside the pipeline. Once the trapped air had a controlled exit, the existing pump could perform as intended. On the third day, Mara found a small amount of water in the gravel basin. She inspected the valve immediately. It was not leaking continuously. The water had been released during startup and had drained exactly where she intended. The surrounding soil remained firm. The riser had not shifted. The first installation would have washed the soil away. The revised version treated the discharged water as part of the design, rather than an unexpected problem. By the fourth day, Daniel stopped standing beside the pressure gauge during every cycle. He returned to pruning damaged branches and checking the youngest trees. Many had already begun recovering. The leaves were still stressed, but they no longer remained tightly curled through the evening. The soil beneath the drip zones was moist again. At the far end of the orchard, the weakest row showed the clearest improvement. Before the repair, those trees received only a thin, uneven stream. Now each sprinkler reached the full root zone. Mara pushed a soil probe beside one of the young trees. The moisture extended several inches below the surface. "We reached them in time," she said. Daniel examined a branch. Most of them. A few trees had suffered permanent damage during the weeks of unreliable irrigation. Mara marked them for replacement. The repair had saved the orchard. It had not erased the cost of the failure. On the fifth afternoon, Mara performed the most demanding test. She shut the system down during peak heat, waited 30 minutes and restarted it, while 3 irrigation zones were open. The valve released air immediately. The pressure rose more slowly than during the morning tests, but it rose evenly. No knocking came from the buried line. The final sprinklers began operating less than 2 minutes later than normal. Mara wrote the result in her notebook. Daniel stood behind her. "How many tests do you need? Enough to know the problem is gone, not just hidden." And she reviewed the readings. The same stable pattern had appeared in every cycle. The valve opened at startup. Air escaped at the high point. The pressure remained steady beyond it. The orchard received a complete watering cycle. "It is working," she said. Daniel looked toward the hillside. For weeks he had expected the pressure to collapse again. He had listened for the knock every time the pump started. Now the only sound was the regular movement of sprinklers through the orchard. That evening, he removed the replacement estimate from his truck. The paper had been folded so many times that the edges had begun to tear. He placed it on the kitchen table beside Mara's notebook. The estimate called for a new pump, new controls, and replacement of much of the main line. The total cost was more than the farm could afford. Daniel looked at the final number. "How much did your repair cost?" Mara calculated the valve, fittings, gravel, and replacement coupling. "Less than 1% of this." Daniel shook his head. "All that money we already spent. The teams repaired real weaknesses, but not the failure. No." He looked through Mara's pressure records. Every page showed the same thing. The pump had continued creating pressure while the orchard lost flow. The air pocket had been the missing connection between those two facts. Daniel closed the notebook. "I thought you were refusing to listen to the professionals." "I was listening." "Then why did you keep questioning them?" "Because their answers did not explain all the symptoms." She pointed toward the old glass on the windowsill. The bubbles, the knocking, and the temperature changes had to belong to the same problem. The professional teams had treated each symptom separately. Mara had connected them. The next morning, Daniel started the irrigation system alone. The valve released a brief hiss from the hillside. Water reached the first row, then the second. Finally, the sprinklers at the far end began turning. Daniel waited several minutes. The pressure did not fall. He walked back toward the barn without checking the gauge again. It was the first full irrigation cycle he trusted. The real test began 3 days later. A heat warning covered the county. Temperatures were expected to remain above 100 degrees for most of the week, with strong afternoon winds and no chance of rain. By noon on the first day, the orchard soil had already begun drying faster than normal. The youngest apple trees showed stress first. Their leaves curled inward to reduce moisture loss. Several trees near the southern boundary drooped before the afternoon irrigation cycle began. Daniel checked the storage tank. "We need to run 2 extra cycles today." Mara looked at the water level. "If we do that all week, the tank will be nearly empty before the next delivery. If we do not, we lose the new trees." They divided the orchard into 3 priority zones. The youngest trees would receive full cycles. The mature trees would receive shorter cycles. The strongest rows would be monitored and watered only when the soil moisture fell below the safe range. The plan would conserve water, but it required the irrigation system to restart more frequently. That meant the air release valve would have to operate several times each day. Every restart created another chance for air to enter, collect, or disturb the flow. Mara inspected the valve before the afternoon cycle. The protective cover was secure. The gravel basin was dry. The riser remained straight. She opened the isolation valve fully and signaled to Daniel. He started the pump. The valve hissed. Air escaped for several seconds. Then the sound stopped. Water reached the first orchard zone. Mara watched the middle pressure gauge. The needle rose steadily, paused and continued upward. At the far end of the orchard, the last sprinklers started. No knocking came from the pipe. The first cycle completed normally. The second began during the hottest part of the afternoon. This time the valve hissed longer. The air inside the exposed sections of pipe had expanded in the heat. More of it had to leave before the water column stabilized. Daniel stood beside Mara. It is taking longer. Still within the safe range. What happens if the valve does not close? We shut down the pump and isolate it. And if it does not open, the pressure beyond this point will begin fluctuating again. They watched the outlet. A broken spray of air and water entered the gravel basin. Then the valve closed. The pressure held. The orchard completed another cycle. By evening, most of the young trees had recovered. Their leaves opened slightly as the temperature fell. The system had survived the first day. The second day was harder. The morning temperature was already high before sunrise, and the tank level had dropped more than expected. Mara reduced the duration of the mature orchard zones by 15 minutes. Daniel disagreed. The fruit trees need water too. They have deeper roots. That does not mean they can go without it. They are not going without it. They are getting less so the youngest trees survive. He looked across the orchard. Every row represented years of work and income the family could not afford to lose. Choosing between them felt like deciding which part of the farm mattered most. Mara checked the soil beneath a mature tree. Moisture remained several inches below the surface. Then she checked a young tree near the southern boundary. The soil was much drier. The older rows can tolerate one shorter cycle, she said. Daniel finally nodded. They started the system again. The valve released air and closed normally. Halfway through the cycle, however, Mara noticed a faint change in the pressure gauge. The needle began moving slightly, not enough to affect the sprinklers, but enough to deserve attention. She walked uphill to the vent assembly. The valve was closed, but a small amount of moisture had collected beneath the protective cover. Mara shut down the system. Daniel reached her several minutes later. The orchard was still receiving water. The gauge was beginning to fluctuate. She removed the cover. A small piece of dried plant material had lodged near the vent opening. It had not blocked the valve completely, but it was restricting its movement. The system was still working because most of the air had already escaped. During the next restart, the obstruction could have prevented the valve from opening fully. Mara cleaned the opening and inspected the internal float. Daniel looked at the small fragment in her hand. That could stop the entire system again? Not immediately, but eventually, it could stop enough air from leaving to recreate the same problem. The valve had solved the central failure, but it had introduced a new maintenance point. A small device at the highest point of the pipeline now protected the entire orchard. That meant it could not be ignored. Mara added a fine protective screen around the cover openings, leaving enough space for ventilation. She also created a daily inspection routine. Check the outlet, test the isolation valve, inspect the gravel basin, listen during startup, compare the middle and final pressure readings. The repair was no longer only a piece of hardware, it was part of the farm's operating system. They restarted the irrigation. The valve released a strong burst of air. The pressure needle steadied. Water reached the final row. By the fourth day, the heat had become severe enough that several neighboring orchards reduced irrigation to avoid emptying their reservoirs. The Bennett tank had fallen below half. Daniel stood beside the gauge. If the system fails now, we do not have time for another repair team. It will not fail without warning. You cannot know that. No, but we know what warning signs to watch. The distinction mattered. Before Mara's investigation, the failure had appeared sudden. Now they understood its sequence. A longer venting time, pressure fluctuation below the high point, knocking in the line, weakening flow at the final rows. The system could still develop problems, but it was no longer silent about them. That afternoon the wind strengthened. Hot air moved through the orchard, pulling moisture from the leaves faster than the roots could replace it. Several young trees began wilting despite the morning cycle. Mara scheduled one short emergency watering for the southern rows. Daniel watched the declining tank. This is the last extra cycle. I know. They started the pump. The valve opened. For several seconds, air rushed through it. Then came water. The valve closed. Pressure moved through the line without hesitation. At the far end of the orchard, the sprinklers rose and began turning. Mara walked between the rows while the water entered the soil. The heat remained intense, but the trees no longer looked abandoned. The system could not remove the drought. It could not create more water. It could only make sure the water they still had reached the roots that needed it. On the 6th day, the temperature finally began to fall. The forecast still showed no rain, but the most dangerous period had passed. Mara and Daniel counted the losses. 7 young trees had died. 11 more showed damage but were likely to recover. The rest of the orchard remained alive. Daniel stood beside one of the failed trees. "I thought fixing the pipe would save all of them." "It saved the system. That is not the same thing." "No." Mara looked across the surviving rows. A working irrigation line could not reverse damage already done. It could not guarantee that every tree survived extreme heat. But without the repair, the losses would have spread through the entire orchard. The air release valve had not created a miracle. It had restored control. That evening, Mara completed the final pressure check. The pump remained within its normal range. The middle gauge was steady. The final row pressure had not fallen during any full cycle that week. Daniel closed the pump house door. 3 teams wanted to replace the system. They were trying to make it stronger. "And you made it breathe." Mara looked uphill toward the small covered valve. The orchard had now survived repeated restarts, peak temperatures, and its highest water demand of the season. The heat had tested more than the repair. It had tested whether Mara's insight could hold when failure carried a real cost. It did. The 3 repair teams returned 2 weeks later. Daniel had asked them to review the system before the orchard entered its next irrigation phase. He wanted confirmation that the repair was safe, not just effective. The lead pump technician checked the motor first. The current draw was lower than before. The housing was no longer overheating, and the pump maintained steady pressure under normal load. "The pump is working within range," he said. Mara did not remind him that the first team had recommended replacing it. The pipeline crew tested the repaired coupling and inspected the exposed high point. There was no water leak. The riser remained stable. The gravel basin had absorbed every small discharge without erosion. The irrigation specialist placed digital gauges at the pump house, below the air valve, and at the final orchard row. They ran the system through a full cycle. At startup, the small valve hissed. Air escaped, then the valve closed and pressure rose evenly through the line. The technicians waited for the familiar knocking. It never came. 20 minutes passed, then 40. The final gauge remained stable. The lead irrigation specialist looked through Mara's records. "You tracked every shutdown and restart? For 12 days? And the pressure loss did not return?" "Not after the vent was installed correctly." He walked uphill to the raised section. "Why did you inspect this point?" Mara showed him the original pipeline map. The system was supposed to descend continuously. She then pointed to the rebuilt service road. "But the ground changed after this map was drawn. The pipe now rises before dropping toward the orchard." The pipeline technician crouched beside the vent assembly. "That created an air pocket." "Yes, and the damaged coupling was drawing in more air during shutdown." Mara handed him the old cracked seal. He examined it in silence. The pump technician looked toward the orchard. "So the stronger pressure temporarily forced water past the pocket. But it did not remove the cause," Mara said. The irrigation specialist nodded. "Increasing pressure may also have compressed the air and made the readings harder to interpret." Daniel folded his arms. "You all tested the system." No one answered immediately. Finally, the lead technician spoke. "We tested the components most likely to fail. The pump," Mara said, "the valves, the filters, the outlets, but not how the entire line had changed with the land." The technician looked at the raised road. No, it was not a dramatic confession. No one had been careless. The teams had followed reasonable procedures based on the original design, but each group had focused on its own section of the system. The pump team studied the source. The pipeline team searched for leaks and solid blockages. The irrigation team measured performance at the trees. Mara had followed the failure from beginning to end. She had connected the bubbles, the temperature changes, the knocking and the pressure drop beyond the high point. The irrigation specialist restarted the system one final time. The valve opened. A short stream of air escaped, then water moved quietly toward the orchard. He looked at the small covered assembly. "How much did this repair cost?" Mara told him. It was less than 1% of the proposed replacement estimate. Daniel watched their reaction. "So the whole system never needed replacing?" The specialist answered carefully. "The system still has aging parts. Some may need replacement in the future. But this failure was caused primarily by trapped air and uncontrolled air entry. The distinction mattered. Mara had not proven that every professional recommendation was useless. She had proven that replacing the whole system would not have addressed the hidden reason it kept failing. The pump technician turned to her. "You do this kind of work professionally?" "No." "Engineering?" "No." "Then how did you find it?" Mara looked toward the far orchard row. "I knew the sound was new." That was where the investigation had begun. Not with a complicated formula, not with expensive equipment, with the recognition that the system was behaving differently than it had before. She continued. The pump still had pressure. The orchard lost flow. Air came out after the knocking, and the problem became worse in the heat. "You treated the symptoms as one problem," the technician said. "Yes." He looked at the valve again. "We treated them separately." Before leaving, the pipeline crew updated the system map. For the first time, it showed the raised section created by the repaired road. Beside it, they marked the new vent assembly and the replaced coupling. The professional teams had arrived expecting to inspect a temporary farm repair. Instead, they documented it as part of the permanent system. Daniel remained near the pump house after the trucks left. "They finally admitted it," he said. "They confirmed it. That is not the same. Confirmation matters more." Mara started the afternoon irrigation cycle. The valve hissed briefly from the hillside. The sprinklers began turning across the orchard. Daniel listened. No violent knock, no falling pressure, only water moving where it was supposed to go. 3 professional teams had tried to repair the system by replacing what they could see. Mara had fixed it by understanding what they could not. The orchard recovered slowly. The 7 dead trees were removed and replaced the following spring. The damaged rows produced less fruit that year, but the farm survived the season without replacing the pump or rebuilding the irrigation line. Mara added the air valve to the maintenance schedule. Before every hot season, she checked the vent, the coupling, and the pressure at the final row. She also updated the old pipeline map so future repairs would reflect the actual shape of the land. The service road still looked ordinary. Only a small protective box marked the point where the entire system had once failed. Daniel kept the first repair estimate in the pump house. Beside it, he placed the clear glass Mara had used to collect the bubbling water. One afternoon, he found her checking the valve before starting irrigation. "Do you ever think about how close we came to replacing everything?" he asked. Mara tightened the protective cover. "The new system probably would have worked." "That is not the point. No. The proposed replacement would have solved the symptom by removing the old line entirely, but it would have cost nearly everything the orchard earned that year. More importantly, the family would never have understood why the original system failed." Daniel looked toward the sprinklers. "What made you question the diagnosis?" "The pump still had pressure. Everyone knew that. The water still reached part of the orchard. They knew that too. And air kept coming out after the pipe knocked." Daniel nodded. The facts had been visible. What changed was the question. The professional teams had asked, which component is failing? Mara had asked, what is stopping the water between the working pump and the dry trees? That question led her away from the equipment and toward the shape of the pipeline. The road repair had raised one section. The damaged seal had allowed air to enter. The high point had trapped it. The hotter the day became, the more the air expanded and disrupted the flow. None of those facts meant much alone. Together, they explained everything. Mara started the pump. A short hiss came from the valve on the hillside. Then it closed. One by one, the sprinklers began turning through the orchard. Daniel listened for the old knock. It never came. "You fixed what 3 teams could not," he said. Mara watched water reach the final row. They were looking for something broken. "And you?" "I looked for something trapped." The repair itself had been small. The insight behind it was smaller still. The problem was not always a lack of force. Sometimes, pressure failed because something had nowhere to escape. By sunset, The orchard had completed another full irrigation cycle. The storage tank was lower, the trees were wet, and the old pump continued working exactly as it had been designed to work. At the entrance to the pump house, Daniel hung the clear glass beneath a handwritten note. Before replacing the system, ask what the system is trying to tell you. 3 professional teams had tried to push the water harder. A farmer's daughter saved the orchard by giving the air a way out.